What's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about interest rate swaps. This is my last video in the series of financial mathematics and SMFM preparation. So in this last lesson, I'm going to talk about spot rates, forward rates, interest rate swaps, net swap payment, and market value. First, let's get started off with spot rates. To understand what is a spot rate, let's consider this example. The following table is an example of a yield curve. Here, I give you a table of two columns. The first column is the term of loan or investment in terms of years. And the second column is the effective interest rate per annum. Here, the rates in this table are called spot rates. Suppose we invest $1 now for 2 years, we would have 1.0535 square at the end of 2 years because the spot rate for a loan of 2-year terms is 5.35%. If we invest $1 now for 5 years, we would have 1.0605 to the fifth at the end of 5 years because the spot rate for a 5-year term of loan is 6.05% per annum. So the T-year spot rate is basically the annual effective interest rate earned on an investment made for T years. So the accumulated value is the present value times 1 plus RT to the T. Here RT is the T-year spot rate. So the spot rates tell you the effective interest rate per annum for an investment made at time 0. What if we have an investment that is invested at a future point of time, suppose at time 3 or time 4. So to determine the present value and the accumulated value for an investment that is not made at time 0, we need to use forward rate. So the second thing I want to talk about is the forward rates. A forward rate is an interest rate that will be earned on an investment made at a future point in time. It is expressed as an annual effective rate of interest. We use notation FT1T2 to state the effective interest rate in effect between time T1 and time T2. Example: how will you explain the following forward rate? The 2-year forward rate that for 4 years is 4%. So this terminology means that we could make an investment 4 years from now that would earn 4% per annum over the next 2 years. So suppose you invest $10,000 at time 4, then at time 6, the accumulated value should be 10,000 times 1.04 square. So the difference between the spot rate and the forward rate is the forward rate is for an investment that make at a future point in time, and the spot rate is the effective interest rate for an investment that is made at time 0 at the initial time. As we know, the spot rate is the effective interest rate for an investment made at time 0, and the forward rate is the effective interest rate for an investment made at a future point of time. There should be a relation between forward rates and spot rates. So I'm going to show you how to determine the forward rates from spot rates. Here is an example. Suppose we are given that the 1-year spot rate is 5% and the 2-year spot rate is 5.5%. What is the 1-year forward rate that for 1 year? So the question is asking about F12. Here, using 1-year spot rate 5%, suppose we invest $1 at time 0. At time 1, the amount we have is 1.05. Now we reinvest 1.05 at time 1 to receive the money at time 2. So we are going to use the deferred forward rate, F12. So 1.05 is the amount of money at time 1. Times 1 plus F12, we got, this is the amount of accumulated value at time 2. And if we use the 2-year spot rate 5.5%, then $1 invested at time 0 will accumulate to 1.055 square. Therefore, 1.05 times 1 plus F12 is equal to 1.055 square. From here, this is an equation of F12. So it's easy to solve for F12. F12 is 1.055 squared over 1.05 minus 1, which is 6.0024%. In general, Ft1, T2 can be determined from spot rates as follows. Ft1, T2 is 1 plus RT2 to the T2 over 1 plus RT1 to the T1. The whole thing to the power of 1 over T2 minus T1. And then subtract the whole thing by 1. Next, interest rate swap. Suppose that your company has borrowed money but has no cash on hand. Business loans are made on a variable or adjustable rate basis. This means that the interest rate is not fixed in advance. Instead, the rate flows from period to period in accordance with some kind of index, LIBOR or prime interest rate. The LIBOR index is under the terms of the loan. The variable interest rate would be expressed, for example, as LIBOR plus 125 BPS. This means that the interest rate for each period is the variable LIBOR rate plus 125 basic points, which is equal to 1.25%. And the prime interest rate is the rate at which U.S. banks will lend money to their best customer. Now suppose that your company is concerned that the index could increase substantially in the future to the point where it would become difficult to make interest payments. Your company perhaps would simply be more comfortable with a fixed interest rate in order to be certain of the amounts of its future interest payments. So to deal with the varying interest payments, the company should think about a third party to make a swap contract. So an interest rate swap is basically an arrangement between two counterparties where the first counterparty pays fixed interest to the second counterparty and the second counterparty pays variable interest to the third counterparty. So under the swap contracts, suppose your company is company A. Arrange the swap with the third party B, not the lender. Company A and B, the party to the interest rate swap, are known as counterparties. Under the term of the swap, Company A will pay Company B the fixed amount of interest every period, and the Company B will pay Company A the variable interest amount every period. In actual practice, rather than having both counterparties make payments every period, one of them would pay the net amount to the other. That means in a period, if the fixed amount of interest exceeds the variable amount of interest, Company A will pay the excess to Company B. Otherwise, Company B will pay the excess to Company A. Example of swap contract. Suppose your company is Jordan Corporation, which has borrowed $500,000 for 2 years at a variable interest rate. Jordan Corporation will make 2 payments to the lender, the first at the end of 1 year and the second at the end of 2 years. At the end of 2 years, it will also repay $500,000 to the lender. So let's say that the counterparty with whom your company entered into an interest rate swap is B Corporation, and that both counterparties agreed that the fixed interest rates will be based on specified spot rates. R1 is 5% and R2 is 6%. So the forward rate, the 1 year forward rate therefore at time 1 is F12, which is equal to 7.010%. Therefore, Jordan Corporation will pay to its swap counterparty, which is B Corporation, 5,000 times 0.05 at the end of 1 year and 5,000 times 0.70110 at the end of 2 years. To levelize the payments, here because the payment at the end of 1 year and the payment at the end of 2 years are different, so we think about how to levelize the payment, that means make them equal. So let's R be the level interest rate swap. We got 500,000 times 0.05 over 1.05 plus 500,000 times 0.07010 over 1.06 squared is equal to 500,000 R over 1.05 and 500,000 R over 1.06 squared. So here, the first term here, 500,000 times 0.05 over 1.05 is the present value of the first payment, and the second term is the present value of the second payment. And we want to levelize using only one fixed interest rate, that's called interest rate swap R. So 500,000 times R over 1.05 is the present value of the payment at the end of 1 year using interest rate swap R, and 500,000 R over 1.06 squared is the present value of the second payment at the end of 2 years using interest rate swap. So from here we are going to solve for R. So R is the interest rate swap. A general formula for the swap rate is R is equal to summation of QTI FTI minus 1 TI PTI over QTI PTI, where RT is the 2-year spot rate, QTI is the notional amount, that is the basic for interest payment at time T. If Q is a constant, then we have Q can be cancelled from the numerator and denominator. If Q is increasing over time, we have a accreting swap. If Q is decreasing over time, then we have a amortizing swap. FTI minus 1 to TI is the forward rate during the period between time T minus T of I minus 1 and TI. And PTI is the present value of a T-year zero coupon with a $1 maturity value. R is the interest rate swap. And we have two types interest rate swap when Q is a constant. When Q is constant, we either can have intermediate swap or deferred swap. Assuming that Q is a constant, then the intermediate swap is R is equal to 1 minus PTN over summation of PTI. Example for 3-year swap, R is 1 minus P3 over P1 plus P2 plus P3. And the deferred swap is R is equal to P0 minus PTN over summation of PTI. An example for a 2-year deferred 3-year swap is R is equal to P2 minus P5 over P3 plus P4 plus P5. Net payments and market value of swap. Since when you enter a swap contract, you pay and also receive sometimes you pay more than you receive, and sometimes you receive more than you pay. So there is an amount that we call net payments. So if the fixed interest rate, if the fixed interest payment is greater than the variable interest payment, excess is paid by the first counterparty to the second. If the variable interest payment is greater than the fixed interest payment, the excess is paid by the second counterparty to the first. That is the meaning of net swap payment. Now the net interest payments. This is the interest paid on the loan combined with the net swap payments. If the counterparty that has the loan receive a net swap payment, the net interest payment is the interest paid on the loan minus the net swap payment. If the counterparty has the loan max a net swap payment, the net interest payment is interest paid on the loan plus the net swap payment. And the market value of the swap is basically just the present value of the net interest payment. So interest rate swap can be sold or closed by either the counterparty at any time. Market value equals present value of future cash flows based on the spot rates and effect on day of sale. So that is everything about interest rate swap. Now let's do some practice. Question number 1. The term and price of zero coupon bonds are given in the following table. Here we are given a table of 2 columns. The first column represents the time to maturity, and the second column is the price of the corresponding bond. Mark entered into a deferred swap. He wants to swap the floating interest rates for a fixed interest rate during the 2nd, 3rd, and 4th years. The level notional amount of the swap is $1,000 each year. Determine the swap rate. Here there are 2 things you need to pay attention. The first information is during the 2nd, 3rd, and 4th years. So this is a deferred swap rate, and it's at the level notional amount of the swap is 1,000 each year. That means Q is a constant. So using the deferred rate swap rate, we got R is equal to B1 minus P4 over P2 plus P3 plus P4 because we consider the 2nd, the 3rd, and the 4th years. So that is 0.98 minus 0.83 over 0.91 plus 0.87 plus 0.83, which is 0.0575. So the swap interest rate during the 2nd, 3rd, and 4th years, the fixed interest rate is 5.75%. Question number 2. You are given the following spot rates. R 0.25 is 2.2%, R 0.5 is 2.8%, R 0.75 is 3.1%, and R1 is 3.7%. Consider a 1-year interest rate swap with a notional value of 300 in the 1st quarter, 200 in the 2nd quarter, 600 in the 3rd quarter, and 400 in the 4th quarter. Determine the swap interest rate per quarter. So here we got Q1 is 300, Q2 is 200, Q3 is 600, Q4 is 400. They are not equal, so this is a non-level notional value. So to determine the swap interest rate, we need to determine the forward rate during each quarter, and we need to determine the price. So to determine the forward rate, we got F 0 to 0.25 is 1.022 to the 0.25 minus 1, which is 0.05455. The forward rate during the period from 0.25 to 0.5 is 1.028 to the 0.5 over 1.022 to the 0.25 minus 1, which is 0.0084. F 0.5 to 0.75 is 1.031 to 0.75 over 1.028 to 0.5 minus 1, which is 0.00913. F 0.751 is 1.037 over 1.031 to the 0.075 minus 1, which is 0.0135. The second thing is determine the price. So P1 is the price of a zero coupon bond that is invested during the third quarter. So P1 is 1.022 to the negative 0.25, which is 0.9946. P2 is the present value of a bond, the price of a bond, a zero coupon bond, during half year. So P2 is 1.028 to the negative 0.5, which is 0.9863. And similar, we got B3 is 0.9774 and P4 is 0.9643. Now we use these information. We got the swap interest rate is R is, we take is value of the notional value times the forward rate and the price, and then add these four terms together. Then at the denominator we have the first term is 300 times with P1, and then 200 times P2, and so on. So the swap interest rate is 0.0094, which is 0.94%. Question number 3. Tim borrowed $1,000 for 2 years at a variable interest rate. Tim will make an interest payment to the lender at the end of each year and also repays $1,000 at the end of 2 years. The 1 year spot rate is 3% and the 2 year spot rate is 4%. Tim decided to enter into an interest rate swap to fix the interest rate for 2 years. Determine the level of swap rate R. Here again, the notional value is 1,000, and to determine the level of swap rate, we got R is 1 minus P2 over P1 plus P2. This is the intermediate swap. So that's equal to 1 minus 1.04 to the negative 2 over 1.03 to the negative 1 plus 1.04 to the negative 2, which is 3.98%. Question number 4. Tim borrowed $1,000 for 2 years from MZH Bank at a variable interest rate. Tim will make an interest payment to the bank at the end of each year based on the 1 year spot rate at the start of that year, and also repays $1,000 at the end of 2 years. The current 1 year spot rate is 3%, the 2 year spot rate is 4%. Tim decided to enter into a 2 year interest rate swap with annual settlement periods under which he will swap the variable interest rate for a fixed interest rate. 1 year has passed. Determine the market value of swap, assuming that the 1 year spot interest rate today is 4.6%. So here, to determine the swap rate, the market value, here the question asks for the market value of the swap. So first we have to find the net payment, and then we find the present value of the net payment. And here the question considers only the first 1 year. So first we determine the swap rate. R is equal to 1 minus P2 over P1 plus P2, which is 0.0398. Now during the first year, the fixed interest is 0.0398, and the spot rate during the first year is 0.046. So that means the net swap payment is 0.046 minus 0.0398 times 1,000, which is $6.2. Now the market value of this swap is basically the present value of the net swap payment. So the market value is 6.2 over 1.046, which is 5.93, because 46% is the spot rate, the 1 year spot rate. Question number 5. You are given the following spot rates: R.25 2.2%, R.5 is 2.8%, R.75 is 3.1%, R1 is 3.7%. Naeem has a variable rate loan of $1,000 for 1 year. He entered into a 4-quarter swap rate. He wants to swap the floating interest rates on his loan for a fixed interest rate. The level notional amount of the swap is $1,000 each quarter. Determine the net swap payment that will be made at the end of the first quarter and specify whether Naeem pays or receives this net swap payment. So to determine whether Naeem pays or receives this net swap payment, we first determine the amount that Naeem pays and the amount that Naeem will receive during the first quarter, then compare them. So during the first quarter, Naeem will pay a fixed interest payment corresponding to the swap interest rate. Here the swap interest rate is R, which is equal to 1 minus 1.037 to the negative 1 over 1.022 to the negative 0.25 plus 1.028 to the negative 0.5 plus 1.031 to the negative 0.75 plus 1.037 to the negative 1, which is 9.1%. So that means during the third quarter, he pays 9.1% of $1,000, which is $9.1 during the third quarter. And also during the fourth quarter, he received 1.022 to the negative 0.25 minus 1, the whole thing times 1,000, which is $5.46. So that means he paid 9.1 and he receives 5.46, which means under this swap contract, he pays $3.64. So that is everything of today. Thank you so much for watching my video. I hope you guys enjoyed my video and I hope it's helpful for you to practice for SMFM. This is my last video ever, and you will never have any other video in the series of financial mathematics and SMFM.